All right, so like I said before, today we're talking about slope-intercept form. Slope is another word that means rate of change, and it's the rate of change between any 2 points on your line. Okay, it is the measure of the rate of change. So to find the slope of a line, there's a couple of different ways you can approach it, depending on what you're given. If you're given a graph, the way you calculate the slope is rise over run. So like if you're looking at this example over here, to get from one point to the next point, you rise 3, run 2, and so your slope is 3 over 2. Okay? The rise is how much you're going up, and the run is how much you're going to the right. So let's say your line was going like down or to the left. How would you change those values? You make them negative. Yeah, exactly. So right and up is positive, down and left are negative. Yes, sir. You may. Another way to think about this is it's the change in the y value. By the way, this little triangle is actually a Greek letter delta, and what it means is change. Okay? So change in y over change in x. And if you want to be a little bit more explicit about it, like let's say you're given 2 coordinates and you want to find the slope between those 2 coordinates, you would, like if you have 2 points like, and we call them x1, y1, and the xy coordinate for point 2, so x2, y2. The formula for finding the slope between those 2 points would be y2 minus y1 over x2 minus x1. Any way you want to think about it is fine. Just know that they're all referring to the same thing, which is slope, rate of change, or what do we call this if you have direct variation? If your linear function shows direct variation, yeah, that's the constant of variation. Okay? What is the name of the point where the graph crosses the y-axis? Do y'all remember that from last year? The name of the point where the graph crosses the y-axis. In this particular case, it is the origin. But in general, it might not cross through the origin. It's going to be called the y-intercept. All right. Similarly, wherever the graph crosses the x-axis, that is called the x-intercept. There's a lot of different types of slope in terms of what you might see. If your graph is going up and to the right, then you have a positive slope. Okay? If it's going down and to the right, so up to the right, down to the right, then it has a negative slope. If it's a horizontal line, like it's just going left and right, then you have a slope of 0. The slope is just 0. If you're going up and down, the slope is undefined. So if you have a vertical line, the slope has no value. There is actually no slope. So a linear equation in the form y equals mx plus b is in what we call slope-intercept form, where the m value is the slope and the b value is the y-intercept. So if you're looking at a graph, it's usually pretty easy to write an equation in slope-intercept form because typically you can clearly see what the y-intercept is, and then you can figure out the slope by doing rise over run. Any questions so far? Okay, so we're going to start by identifying the slope and the y-intercept from an equation, and I want to show you how to graph this by hand. Now, you should know that you're going to have the ability to graph it on a calculator and on Desmos, but I want you to know how to do it without that too. Okay, so you have a better understanding of where this graph is coming from. So for 2a, what's the slope? Negative 3/4. What's the y-intercept? 2. Right? Okay, easy enough. What's kind of special about b? What does b have that the other ones don't? Think about what we learned last time. All right, well, before we answer that question, what's the slope here? What is the coefficient to x? 5. And what's the y-intercept? It's 0. And just kind of cycling back to what we learned last time, if you have a linear function that has a y-intercept of 0, meaning it goes through the origin, what can we say about that relationship? What does it have? Y'all just took a quiz over it. Yeah, it's got direct variation. Okay, so I'm just going to make a little note here. This has direct variation. Now, C is not in slope-intercept form. So we need to put it in slope-intercept form before we can identify the slope and the y-intercept. These are going to be the kind of annoying problems because you have to actually work with it algebraically. But usually you're going to do the same couple of steps every time. The first thing you're going to do is try to move the term that has x over to the other side. So I'm going to subtract 6x from both sides. Now, can I combine these two terms to make it like 18x? No, they're not like terms. 24 does not have an x, so they're not like terms. So now I have 4y equals negative 6x plus 24. The reason why I'm writing that x term first is because I want it in that mx plus b format. Okay, so what else do I need to sort of do here to get y by itself? Divide by what? 4. Yeah, divide by 4. And I need to divide everything by 4. So y equals negative 6 over 4. By the way, we can reduce that, but we'll reduce that later. And what's 24 divided by 4? 6. Okay, so what's the slope? Negative 6 over 4, which does reduce to 3 over 2. It's not a huge deal that you don't know that, but just keep that in mind. And what's the y-intercept? 6. So once you get it in that form, that's why it's called slope-intercept form, is because the slope and the y-intercept are explicitly stated in the equation. All right, let's take a look at a couple of these graphs. So D, what'll be easier to calculate here, the y-intercept or the slope? Like, what can you tell just by looking at it? Yeah, the y-intercept. What is the y-intercept here? The y-intercept is 1. The slope is something that we're going to have to calculate. Okay, that's where we're going to use our rise over run. So I'm actually rising downward. So what is my rise or my change in y? 5. But since I'm going down, negative 5. And then I'm going to the right, how many spaces? 5. So my slope is negative 5 over 5. What does that reduce to? Negative 1. All right, for E, what's the y-intercept? Let's do the easy part first. Negative 2. Okay, and then the slope. Here's my rise, I'm going up, run, I'm going to the right, so I'm expecting a positive slope here. So what's my rise or my change in y? From negative 4 to 4. How many units am I going up? 8. So that's going to be a plus 8. And then how many am I going to the right? 4. Wait, 4? 3?
Couldn't you just do 2 points that meet like a perfect point? Like to any points?
Yeah, you could pick other points for sure. Like you could pick these 2 points, right? And then your slope would be up 2 over 1. So is 8 over 4 the same as 2 over 1? Yeah, what do both of those equal? Like what's 8 divided by 4 or 2 divided by 1? 2, right? And so this really gets to the heart of what makes this function linear, right? The defining characteristic of a linear function is that it has a constant rate of change. And so as long as it's got a constant rate of change, it shouldn't matter which 2 points you pick, no matter how far apart they are, anything, because they'll reduce to be the same. Okay, that's kind of the whole point about linear functions here. All right, now f is kind of weird. What's the y-intercept for f? Well, to be 0, it needs to cross the origin. Like the question is like, where does it cross this y-intercept? It doesn't. None. Okay? If that happens and you've got this vertical line, if you don't remember, look back at the first page, but what do we call the slope? Undefined. Yeah. If you want to think about it in terms of the actual points and doing the rise over run, in this case I'm rising 8 but running 0. 8 divided by 0 is an illegal operation. You cannot do that. So it's undefined. It has no value. All right, G is a little tricky because they're just telling you 2 points. So let's start by finding the slope from these 2 points. So let's first calculate the change in y. If I go from 2 to -1, how do I get there? What do I need to add or subtract to go from 2 to -1? I need to subtract 3. So my change in y is -3. And what's my change in x? How do I get from 0 to 2? Add 2. So my slope will be -3 over 2. Change in y over change in x. Now, notice that I didn't use a formula there. You could use the formula, but I usually recommend against it just because I think doing it like this is a lot easier. But if you're sort of a formula person and you like plugging things in and that's easier for you, you're more than welcome to do that. What's the y-intercept? At first, it might seem like, oh, I got to figure out where the y-intercept is, but it's actually given to you in the problem.
2.
It's 2, right? 0, 2, that's your y-intercept. All right. H, the line that passes through 2, 2, and 4, 2. Let's first try to figure out what the slope is. Okay, so my change in y is what? From 2 to 2, 0, right? I don't add anything. But how do I get from 2 to 4? What's my change in x? 2, right? So what's 0 over 2? 0. When you have a slope that's 0, what kind of line does that indicate you have? Horizontal. Yeah. If you're not sure, you can always go back and look at slope of 0, slope of undefined. So we've got this horizontal line, and that kind of makes sense. Like if you were to do a quick sketch, you've got 2, 2 here, 4, 2 here. So my line has to be horizontal. So what is my y-intercept? What does my y-intercept have to be if that's a horizontal line? 2. Yeah. Okay, so we've gone through equations and graphs and descriptions and come up with the slope and the y-intercept. And we'll use that a little bit more next time to write the equations. But the last thing I want to do with you is to actually graph an equation that's in slope-intercept form. So I'm going to show you how to do that. All right, 9a says we've got 4x minus 4. So what's the y-intercept? Try again. The y-intercept's -4. So let's plot that point. We know it has to cross the y-axis at -4. What's the slope? Not 4x, but just 4. The slope is going to be a number. Okay? Now, because we're trying to graph this and we're going to use that idea of rise over run, it might be easier to graph if our slope is a fraction, because then we'll clearly see what the rise over run is. So how could we rewrite 4 as a fraction? Yeah, 4 over 1 would be 4. So starting from your y-intercept, you're going to go up 4, 1, 2, 3, 4, over 1. up 4, 1, 2, 3, 4, over 1. And draw your line. Any questions about how I got that graph? Let's try the next one. Negative 1/2 x minus 3. So what's the y-intercept? Negative 3. And what's the slope? Negative 1/2. So this one's already written as a fraction, so we don't have to worry about that. So let's just go ahead and start plotting it out. My y-intercept is negative 3, and my slope is negative 1/2. So I'm going to go, since it's negative, it should be going down and to the right. So down 1, right 2. Down 1, right 2. Now if you run out of space on your graph, you want to continue that pattern backwards. And remember that this should be a line. So, you know, if we're continuing back this way, we can plot these 2 points also. Now, what's the problem with 11? Why is 11 going to be a little trickier than 9 or 10? Yeah, it's not in the right form, right? So it's the wrong form. So we got to solve for y here. So I'm going to subtract x from both sides, and that gives me 3y equals negative x plus 6. And then divide both sides by 3, and you got to divide everything by 3. What is the implied coefficient to x here before I divide by 3? Like if you say negative x, what is the implied number right in front of it?
1.
Negative 1, right? So if I do negative 1 divided by 3, that's just going to give me negative 1/3. So negative 1/3 x plus, what's 6 divided by 3? 2. So what's the y-intercept? 2. I'll go ahead and plot that. And what's my slope? Negative 1/3. So since it's negative, I'll go down and to the right. Down 1 over 3. And I sort of run out of space over here, so I'm going to continue it backwards. And there's your line. Any questions?